Building a belay using the rope with inReach anchors. Firstly, take the rope from our rethreaded figure of 8 and clove hitch it to anchor number 1. We then take the rope coming from anchor number 1 and tie another clove hitch to anchor 2, making sure the rope is not taut or tensioned between the two anchors. We then take the rope from anchor 2, bring it back to our rope loop on our harness and clove hitch it to the rope loop using a carabiner. We now have two anchors that are independent of each other and we are connected to both. However, each anchor needs to be made tight by adjusting the clove hitch or hitches where appropriate. If only one anchor is tight, then this will take all the forces generated in a fall scenario. Ideally, we want forces generated in a fall scenario to be equally distributed to both anchors, thereby equally dissipating the forces and helping to protect the integrity of the anchors. This anchor system will only work if the ABC rule is followed and the forces generated in a fall run in the direction of the anchor is orientated. Any deviation from the ABC rule will see forces being exerted unnecessarily on the belayer, possibly resulting in compromising both belayer and climber safety. We have arrived at the top of the route, selected our best anchors available. In this case, we have decided upon using two anchors. Before constructing the anchors, take a moment to understand where the climber is approaching from below, how this lines up with our anchor selection, and where we position ourselves as the belayer following the ABC rule. In this instance, the anchors are high enough to allow the belayer to belay while standing. The anchor positioning, the height of the anchor, and our ability to see our climber below us will determine our belaying position ultimately. You can see in this scenario that the forces generated in a fall would travel up the live rope, in through the belay device, through the rethreaded figure of 8 knot, and then be dissipated equally between the anchors. If the climber in this scenario were climbing directly below the belayer, the ABC rule is not being followed. In the advent of a fall, the belayer will pull towards the ground and may compromise the climber's safety. If we take a closer look, imagine the scenario: we have led a trad route and have organised two excellent anchors. They are both in reach, and in this instance we have decided to build the anchors using the rope. As before, we connect the rope to the first anchor with a clove hitch, making sure to close the gate. We then need to make sure that when we are in the belaying position that the anchor is tight. Any slack could lead to the belayer being pulled towards the cliff edge and shock loading the anchors unnecessarily. We then connect the rope to anchor 2 with another clove hitch, making sure the rope between both anchors is not tensioned. If this rope is tensioned, it means the anchors will not work independently. We take the rope coming from anchor 2 and clove hitch this to our rope loop. Again, we need to make sure that when in the belaying position, the rope to anchor 2 is tensioned sufficiently. We are now attached to two independent and equalized anchors. Again, this anchor setup only works if the belayer considered initially upon constructing the anchors where the forces will come from in the event of a fall and how they will be directed and dissipated. If the belayer deviates from the ABC rule, then the forces may pull the belayer into a dangerous position and shock load the anchors unnecessarily. It is always worthwhile the climber to take the time at the top of a route to consider the stance, consider the construction of the belay and what will work best in a given situation. If the belayer builds an anchor system that is flawed and the climber below starts climbing, then the setup cannot be altered once the climber leaves the ground.